So we are going to finish chapter 4 with talking about natural resources and conservation. Now, this chapter really is about natural resources. Uh, I've we've been focusing so far on talking about energy because the most widely used natural resources on the planet are fossil fuels, along with water and mineral resources. And they're very much a part of our lives. They're the reason that the world has gotten to the place it is today. So it is worth talking about energy and all of those things. And then alternative energy is tasked with attempting to replace what those natural resources, have done for us, much like the internet and YouTube has replaced physical books and encyclopedias and things like that. But now we'll focus on natural resources such as wood for trees and lumber and water as a natural resource and a few other things, and then we'll look at conservation. So part 1 will be on natural resources, and we're going to start with some historical perspective. These giant head statues, I believe they're called moai, are from the island of Easter Island, a tiny island in the Pacific. And it's worth talking about Easter Island for a little bit because of what happened on Easter Island. So here's our planet. Easter Island lies in the Pacific Ocean off the coast of South America, and it is one of the 3 or 4 most isolated places on the planet. It sits right here, this tiny little island. It's only about 12, 13 miles wide is all. And you can see just how isolated it is. People lived here. The people that occupied it, however, died out around the year, I think it was 1100 AD. You'll have to fact check me on that. So European sailors and navigators and explorers like James Cook and others never encountered people on this island. He encountered people in other Pacific islands such as Hawaii and New Zealand and the areas around Australia. But Easter Island, its people long disappeared, and they made a pretty unbelievable choice. On this tiny island where people lived, they decided to completely destroy all of their natural resources. They cut down all of the trees on the island. Now here in the center, and there are some people that live on Easter Island, but not very many. So it's a small volcanic island. Now these trees have been planted over the decades in a concentrated effort to reestablish that. But the rest of the island we can see is virtually completely bare, and it just has low-lying grasses and shrubs. The people of this island civilization cut down trees, but not to build boats, because they gave up boat building when they settled on this island. They did it in order to build houses and to build fires so they could cook food and to manufacture perhaps other types of tools. And one day, the people that lived on this island, because it was so small, they had to have known what the state of things on the island were. But they just decided anyways to cut down every single tree on the island. And then they simply couldn't live anymore after that. They had access to all the food they wanted. They ate mostly fish and clams and things like that from the ocean around them, because obviously there are no large animals that live on the island, and birds only visit it periodically, and birds are very hard to hunt if you don't have firearms. So I highlight this because, yes, some resources, we only have so many of them, and we human beings, we have a choice on what we're going to do with this world we live on. There are many animals that we have already hunted to extinction. There are vast swaths of the planet where we have already cut down all of the trees or most of the trees that are there. And we can live while we keep on doing those things, but at what point are we going to understand, or will it ever be too late for us to understand that our needs and our our size, our population perhaps, and our reach has gone beyond its limit, and then we start to only decline from there to a certain point. I think that that is not an ideal picture of the future, and I don't know how realistic it is because this is a great big world with plenty of some types of resources, but it can happen locally in some places. So we have to be careful and we have to understand these kinds of things from a historical perspective, and we have to understand them from a scientific perspective because that's science is the tool we use to understand our world. So, anyways, we will start with water. It's obviously the most precious resource on our planet. Waterborne diseases and contamination of water kills around 5 million people a year, which is a lot of people, but that number has gone down so much in the last several decades that we've made unbelievable progress. In the developed world, there's infrastructure in place that delivers water everywhere, and we don't even think about it. I can turn on a sink or a watering fountain anywhere in any building or home or business that I go into, and where that water comes it's not even thought of. But we only have to go back a couple hundred years to when people were moving in and settling around these areas. Even your grandparents, if you ask them, when they were children, or maybe they remember when their stories that their parents told them, so your great-grandparents, maybe all of the water that they had access to, they had to get it from a well in their backyard or something like that. And today we don't worry about these kinds of things. But those systems we've seen in the news famously in Detroit, Michigan, the school systems, and in Flint, Michigan, the entire town, with contamination of that water supply. So water is absolutely essential to life. We need it to, in this country, we use it for frivolous things like manufacturing of goods and for our toilets and bathrooms and things like that. Really, if we boiled it down, you just need clean water to drink, and that's about it. Cleaning and manufacturing and all those things come secondary. So if we break down the water on our planet, yeah, only about 3% of it is fresh water, and of that, virtually all of it is frozen. It's in Antarctica and Greenland, so we can't use it. And ocean water is no good for pretty much any human need except for certain industrial processes. You can't use ocean water to irrigate crops. It will kill them because the salt that's in the water will cause the fluids inside the plants to diffuse out, and then they die from that. So the story in Flint, Michigan, just very briefly, is pipes that are under your feet right now that feed water into whether you're at home or whether you're at school right now. Many of those pipes are made out of lead because lead is very malleable, it's easy to shape, and a lot of pipes are made of 100% pure lead. Now, maybe you didn't know that, and you think, well, no duh, they got lead poisoning. Well, it's not that simple. You see, what we do is we add corrosion control chemicals, some compounds like orthophosphates, you can see there in step 2, and they're mixed in with the water. They're non-hazardous for you to drink. They're in very small quantities. And what they do is they bond to the inside of the pipe, and that forms what's called a scale. So it bonds to the lead and neutralizes the lead. It turns it into a non-reactive lead compound. And you can see that person is holding a pipe that's been cut in half, and what's called scale has developed on the inside. Now, if this pipe broke somehow, like maybe from an earthquake or somebody was digging in their yard and they didn't know what they were doing and they cracked a pipe, then that could expose some lead that doesn't have scale built up on it. But that's not what happened in Flint. What happened in Flint was they switched where they get their water supply from, so they didn't switch the infrastructure below their feet. That was the same. But when they changed the source from the water, they started pumping in water through the city that did not have these corrosion control chemicals in the water. So slowly over time, the protective scale that had built up in their pipes eroded away because water can be erosive. It takes a little while to act. But then the lead started to simply leach into the water, and it takes incredibly fine, tiny quantities of lead in order to be poisonous. the the CDC recognizes there is no safe amount of lead to be in water and in our children. So it's an absolute no tolerance kind of thing. So when it comes to water as a resource, we have to understand that there's precious little of it around. Only 1% of it is even usable. There's 100 times more more water below ground than on the surface, but that water should be treated as a non-renewable resource. A significant percentage of Americans live in places where it is only possible to live there because of groundwater. It does not rain enough. There's not enough standing water. These people would not be able to get the water that they need to drink and cook and grow crops if it weren't for the fact that we can pump it out of the ground. But unlike other non-renewables like fossil fuels and things like that, groundwater can run out in several areas around our planet in only a few generations. We've seen it happen before. We've also seen surface water be completely depleted from some certain areas. The Aral Sea, Aral, I believe that's how that's pronounced, in the Middle East has been drained by something like 90% just in the last 50 years or so for irrigation. So that's an entire source of surface fresh water pretty much gone, virtually 100% of it. So the amount of water that we take out of the ground is really unbelievable. These are the states that are most intensive with groundwater, and we can see California pumps between 20,000 million gallons of water every single day out of the ground. So in other words, 20 billion to almost 29 billion gallons of water out of the ground every single day. That volume of material, it's hard to even comprehend how big that is. Now we need to treat it like a non-renewable resource because groundwater gets underground after it rains, but most of the water that hits the ground during rains is absorbed through vegetation and then evaporated back into the air through the vegetation. That's called transpiration. Or it simply runs off the land and ends up in rivers and is then carried away. Or it doesn't really sink into the ground very far and then slowly evaporates back. It takes thousands upon thousands of years in most places for just a few inches at a time of groundwater to accumulate. So if you can imagine, we're pumping 20 billion gallons of the stuff every day out of the ground, which seems kind of hard to believe. We're going to start to run out. Now, we're going to go look at Idaho because Idaho it's the second most groundwater intensive state in the country. And it's worth looking at for the reasons listed a little bit there about people not being able to live somewhere if it weren't for that. So I'm going to get rid of these labels so this is a little more clean. But this is Idaho. Now, southwestern Idaho, which is right here, is technically a desert. If we go over here, it rains so little that, and these obviously aren't sand dunes, but it's just low-lying shrubland and grasses. Nothing that could be supported. But we have these odd ribbons of green all around. Here are the mountains where there's going to be moisture, but this is different. This is all where people have staked a living. So this brown area right here, all of this looked like that, maybe only 150 years ago or so. But it's only through pumping water out of the ground that we're able to terraform the area and just make it green. This is not possible. And we are growing invasive species of crops here. This is corn and wheat and things like that. Now, a dead giveaway that this is groundwater is, look at the fields. Do you see how they're all circles? Why are they circles? Because in the center, you will see one of these irrigation sprinklers. They probably have a fancy name, but I don't know what it is. And you can see this one in the satellite picture is actually turned on. You can see the water coming out. We have these around here, but they're a little more rare because there isn't as much groundwater close enough to the surface around here. But virtually 100% of the fields here, if you look, all have those in there. And it's the only way it works because, like I said, there isn't naturally enough rain here for this kind of growth. And we know that because look at the area where they're not farming. It's not green. Now, if we go to where we live in South Dakota, well, look at just how drastically the eastern part of the United States is green, and then it's dry and brown over here. And we got plenty of green, even where there aren't any farms, even though this is all farms over here. We get close to enough moisture where not all of our agriculture depends on, on irrigation. Now, Idaho, this can't possibly go on forever. And there are hundreds of thousands of people that live in this Ohio basin around here. What are these people going to do when they can no longer get water out of the ground? Because this river might not be enough water for everybody. So we have hundreds of thousands of people that are kind of sort of, it's not really necessarily in the near future, but they're living on a knife's edge here. And it would be a terrible tragedy if they used all their resources and had to pack up and completely redo their lives. Also, for the state of Idaho, agriculture is their number one business. They can't make money in other ways. If you live in California, yeah, California has lots of agriculture, but they have technology empires. Google and Facebook, they're all located, and Apple are located in California. So the state makes money in other ways. Idaho, not so much. So schools and other businesses that are tax funded, since agriculture is their dominant business, well, that's where a lot of the tax revenue is generated as well. So it could collapse the economy of the entire state, not just a few people's means of making a living. So these things are very important to take seriously. As far as water withdrawals, what we use water for, the number one use, and I didn't know this until I started writing this lecture, is thermoelectric power. What the heck does that mean? What this means is it's the use of water in cooling down equipment used to make electricity. So that water can be pulled from the oceans. You can use salt water for that. It doesn't have to be groundwater. And the good thing about this process is because you're just cooling things down, the water is just pumped right back into the environment. And so you probably don't see much of a net loss in water. But if you look at the rest, public supply, that's a very significant use. But irrigation is by far, if we discount the thermoelectric power, I believe irrigation is responsible for something like 77% of all water use. And most of it comes from groundwater. If we look at the top two here, we're going to ignore the green and the orange ones. But the total water withdrawals, if we look, where do we use water from? Mostly it's on the surface, but that's with that gigantic thermoelectric power sector thrown in there. So if we ignore that, which is what the top right pie chart is, we can see that 41% of our water that we use is groundwater, which is a non-renewable resource. So we have to be realistic. We have to figure out what we're going to do if we have to ration our water in the future or what. And then if we break it down by sector, so surface water is in blue and groundwater is in the light tan or yellow or whatever that is. So when it comes to like public supply, the water that you and I use in our homes, that's 2/3 from the surface. Domestic, I'm not sure what that is, but we're using almost entirely groundwater for that. But if you look, the number is very, very small. I don't know if these are thousands of gallons or what is it? Millions of gallons per day is what this is. So whatever domestic is, yeah, you look at it and you see, ooh, that's a lot of groundwater. But the number is actually very low. It's only 3,500. Irrigation, there we go. So 43% of all irrigation is done with groundwater. Livestock, there you go, but that's a very small number again. The rest of these are very tiny. If we look at public supply, that's a very large number of gallons of water. If we look at irrigation, that's very large. The rest of these are kind of negligible. We haven't, so when we look at some of these resources and what we've talked about in class is that things are trending better. We are able to make more fuel-efficient cars. we're able to make or have our manufacturing processes for generating electricity and things like that produce less pollution, even though we're doing more and more of the stuff all the time. But we can't make our water more efficient because that would mean totally changing biology, which we can to a certain extent, but not really. So as our population since 1950 in this country has almost exactly doubled, our use of water, if you look on the bottom here, has also almost exactly doubled. Now, if you look, our total use of water has actually sort of dropped ever since the 80s. So I'm not exactly sure why that is, where we are saving water, but it has gone up. These are groundwater aquifers all throughout our globe, and the ones in red, orange, and yellow are, what that means is the aquifer is having its water drained faster than the water can replenish. If it's in the blue, and the darker blue, the better it is, then water is being replenished faster than it's drawn out. So we can see most of these, the water is receding from these aquifers. So eventually it could run out, and in some of them it's running out quite fast. In North America, very close to where we live, we have the famous Ogallala Aquifer, that's number 17. Now as a whole, that one is gaining water, although it's only, if you look, around 2 millimeters of water a year. But that's not the whole story, because if we look at the Ogallala Aquifer, here it is from Nebraska down to Texas. Only the areas in Nebraska and a few very, very tiny spread out other areas throughout the Midwest. Only the ones in blue is where the water is being drained into the aquifer faster than it's being taken out. So yes, as a whole, the aquifer is not losing water, but we can see that for 70, 60 maybe percent of the aquifer, 60 to 70% of the farms that use the aquifer, they are losing their water. And there are places such as Clovis, New Mexico on the bottom there where the town ran out of water. People, you turn on your sink at home and nothing happens. It's not in the entire town of Clovis, but it has affected many regions in it and many of the rural regions as well. Can you imagine what life would be like for us, even if it only lasted for a month, if you couldn't turn on a sink anywhere and get water? We would have to use bottled water for everything we do that we buy from the store, which is hundreds of times more expensive than city water. City water only costs a couple cents per gallon. You would probably just forget about washing your clothes or taking a shower because you'd be buying your water and you need it for cooking food and to drink to stay alive. And that's much more important than your hygiene. But it would really turn our worlds upside down, even if it was only for a little bit. In California, now this drought is over, but on the left, in around the year 2010, I think was the year the drought got to its absolute worst. And this was due more to lack of rain. It wasn't like humans pumped all the water out of this reservoir here. But these are the kinds of things that can happen. So droughts can happen, and then we lose water. And in California, people were banned from watering their lawns. They had to be so conservative with their water because we need water to drink to stay alive and a couple other things. So we couldn't waste water on frivolous things like our yards and things like that. Okay, when it comes to pollution, we have point source pollution. That means we know exactly where it comes from. And this is useful because then we can figure out, who is breaking the law, or if nothing was done intentionally, we can figure out how to engineer our way out of a problem. However, most water pollution is non-point source. We don't know exactly where it came from. And the reason for this is because of runoff. That is a major, major contributor. When a town, so you think of a city, it's made of asphalt. Asphalt does not absorb water. So when a large urban area experiences heavy amounts of rain, that water simply washes through all the streets and picks up any kind of debris or pollution or gasoline or oil or whatever it is that's on the ground and funnels it into perhaps low-lying areas and then that's where your rivers will be. And then the river can carry that pollution hundreds of miles into many different areas. The, the biggest overall uh, source of pollution in the United States is definitely from agriculture because we have all of these chemical fertilizers in the water. Now, the chemical fertilizers perhaps don't necessarily directly affect our health. We aren't necessarily drinking them directly, but what they do is it causes these massive algae blooms in our river. And we have a river in town that all summer long it's nasty and green. And we're going to go look at it for an environmental science lab in this class. And you're going to see it. And the reason it's nasty and green is because of all the fertilizer that's in there. The plants grow, but then eventually the plants decay and die. And as they break down, things that die and they rot, they produce lots of very, very toxic and harmful and frankly gross kinds of chemicals. And then that can have major impacts on us and on wildlife. And then as far as the oceans, a little bit more bad news. We dump around 8 million plastic tons into our oceans every year. Now, in the United States, we are not the major contributor to that, even though when we look at how much carbon dioxide we produce and how many millions of gallons of oil we burn through a year, yes, we are a world leader in those things because we are industrialized and have a large population. But we do have systems in place. We have governmental and city and local and federal regulations that help us control our pollution. So we have done a very good job for ourselves. But then another thing that all humans are contributing to, well, most humans, is the warming of our planet. That is killing coral reefs at a rate that is so high that it suggests that it is virtually entirely due to human activity. This is very recent news, between 2016 and 2018, in the last 2 years, half of the Great Barrier Reef has died. It's the largest, it's not a single organism, but it's the largest living network on our planet. It's visible from space. It's thousands of miles long. It supports probably the highest density of biodiversity and life on our planet. And half of it has died in 2 years. That's not good. If we look at plastic in the oceans, China is the main offender here. Now, if we look at these countries at the top, China, Indonesia, Philippines, Vietnam, Sri Lanka, Thailand, Egypt, Malaysia, Nigeria, Bangladesh, South Africa. These countries they're not quite on par with, you can see the United States is in there. I'm struggling on how to think to say this in a nice way. They're not developed enough. Their government systems are not efficient enough. They don't have as much control as ones in democratically elected countries like the United States, like virtually every country in Europe has. And so they don't have regulations and control over what they're doing. Now, the United States, of all these countries on here, we have the third largest population. But we are able to keep our pollution, our plastic debris numbers very far down because we're able to control it very well. So we need to get these other countries on our level, basically, with what we've been able to accomplish. So this is what goes on with corals. Those are dead. Now, corals are, let's actually look at a picture of a coral so you know what they look like. They are colonies of tiny organisms called polyps. And the reason that they have all these different colors is because there's a gelatinous sort of animal that lives within the coral. So if I type in coral polyp, you'll see what I mean. So this is the animal, and they look like sea anemones. And what they do is they build up the reef around them. So they live on the surface, and they take in minerals from the water, and they deposit those minerals. And that's what the big structure of the coral is. So if we go back here and look at all these awesome shapes that they take on, the bulk of that is the mineral that the living thing has produced. And the mineral, it's just like calcium carbonate type things. So when it gets bleached, what that means is the polyps die, and all that we have left here is the mineral structure from it. Now you can see all the coral in this picture has been bleached out, and this is what's happened in our Great Barrier Reef. Now, it's not exactly the warming that has caused this. The major offender is the acidity, the pH levels of our ocean. All the carbon dioxide in the air gets absorbed into the water, or a lot of it does at least. But carbon dioxide and water, when you mix them, that's an acid. So the more and more and more carbon dioxide that we put into the air that gets absorbed into the shallow waters in the oceans where corals live, the more and more acidic it becomes. And then this is the result of the problem. Something like 40% of the world depends on calories from food taken directly from the ocean. And the vast majority of that is from reefs because of all the biodiversity there. So this isn't just the reefs are pretty and we should save them. This is our people around the world that are our brothers and sisters. We need to take care of them as well. And we'll move on to the atmosphere there. So the chemical composition of the atmosphere is what maintains life on Earth. Much of that chemical composition is maintained through biology. So if we pretend there are no humans on the planet, there are some sort of number of trillions of trees on our planet. They produce oxygen, right? So does algae in the oceans and things like that. And animals and volcanic eruptions and things like that produce carbon dioxide. And those things fluctuate in the atmosphere, but they're basically kept in balance. Now all of a sudden you add humans to the mix, and humans, we release 45 billion tons of carbon dioxide into the air every year now. What does 45 billion tons look like? I calculated it once, and if you could take all the carbon dioxide and lump it into like solid blocks, you would have a lump of solid carbon that's about the size of 2.5 Mount Everests. So that's really an incredible amount of carbon dioxide. Now the problem is there's all these trees and the water and everything on our planet, and they absorb carbon dioxide. But remember, we've only been doing this for a couple hundred years. The amount of carbon dioxide that plants and oceans are absorbing, that was already in equilibrium, and they can't compensate for the excess amounts of CO2. From what I have read, oceans and plants are able to take in about half of that carbon dioxide. So, over 20 billion tons of the stuff every year. But that means that there's an amount of carbon dioxide that keeps accumulating. And that's why today we're at 0.04% CO2, whereas 150 years ago we were only at 0.024. So we're going to almost double that amount soon. Now, is that a death sentence? No, not exactly. For corals, it could be, and we don't want that to happen, but we looked at that in class as well. So here's our atmosphere. Now, the atmosphere also, the greenhouse effect of our atmosphere is essential for life on our planet. If we had no CO2 in our atmosphere, we would all die. Well, maybe we wouldn't all die necessarily, but it would be, on average, 30 degrees Celsius colder on our planet, which means where we are here in South Dakota, it is 45 degrees today, even though it's late September. It would never get above, it would probably never get above 40 degrees Fahrenheit, even in the warmest months of the year, if we didn't have any CO2 on our planet. In fact, it'd probably be even, maybe would never get above freezing, maybe never above zero. So we need it, but how much is too much? How much warming is too much warming? And there's also ozone in our atmosphere that blocks UV radiation. And we know that human activity has depleted the ozone layer as well. So what you need to know and what you need to understand is that carbon dioxide is not a pollutant. It's a greenhouse gas. So when you talk about pollution, CO2 is not one of them. Now, I have heard people arguing against global warming and climate science that say it's not real. they ask a very stupid question, which is how much carbon dioxide is dangerous for humans, and they ask that because, well, either they would either ask it because they don't understand at all that carbon dioxide will not kill you if you breathe it. But I think they're actually asking it because they know that it's an invalid question and it doesn't have an answer. So the person trying to answer it kind of looks a little silly, and then they're able to say, "Oh, look, they can't even answer the question." Well, no, you breathe carbon dioxide, nothing bad happens. But if it warms up our planet and kills all our coral reefs and tens of millions of people starve to death in a couple decades, yeah, it is harmful to humans in that respect. But anyways, the chief atmospheric pollutants are carbon monoxide, nitrogen oxides, what are called volatile organic compounds, sulfur oxides, lead, and CFCs, which stands for chlorofluorocarbons, which come out of like air conditioners and things like that. Now, when you go and buy gas, it says unleaded gasoline, right? And that was always a mystery to me when I was a kid, because I would think, well, of course it doesn't have lead in it. You can't put lead in gasoline. Lead is it's a horribly poisonous substance. But gasoline contained tetraethyl lead from the early 1900s all the way to the 1990s. Even though as early as the 50s, we knew that the lead coming out of all the tailpipes and all the cars was getting into our water and it was lingering around. It literally coated all of the surfaces in major urban areas. You know, you can't really see pollution around you, but because of everything that's going on outside, there's a thin film of dust and debris from cars and from all kinds of things. And that sort of stuff we can live with, but decades ago there was lead everywhere, and it was causing massive problems. And the oil companies, the fossil fuel companies that obviously make and sell the gasoline, they hired scientists to lie and say that either yes, there's lead in gasoline, but it's not getting into the environment, which is a lie. Or they would say things like, well, lead occurs naturally, so there's no reason for us to assume that the lead that we do find in the environment came from the gasoline, which was, again, a total lie. And it took 40 years for leaded gasoline to be banned. So it took this country 40 years to figure out that, no, we shouldn't be putting aerosolized lead into the atmosphere at the rate of millions of tons of the stuff every single year, which is too bad, but we did finally win that battle. The only reason we were able to win that battle is mostly thanks to concerted efforts and legislation. The air quality in the United States has significantly increased over the decades, so we are fighting a winning battle here. And this is really a gigantic accomplishment because we're producing more than twice as much energy, which means we're burning more than twice as many fossil fuels as we were back then, but we've reduced our pollution, which is an awesome achievement. Another thing that has helped is natural gas power plants have replaced coal-powered power plants because it's cheaper to use natural gas. And also, an added bonus is natural gas, when you burn it, it's much cleaner. New York City in the 70s, it would have smog days where it looked like Shanghai. That picture we've looked at before where it's so gross and cloudy that you can't hardly see anything. That was New York City sometimes, not all the time, but on certain days in the 70s. And it never ever happens anymore because they switched to natural gas. So we don't have to say forget about fossil fuels. We can just use better fossil fuels. And then some other good news is the ozone layer hole that the Earth has. It's over Antarctica for the most part. It is repairing itself. And we, for the first time recently, have some direct evidence that it's from the strict banning of those chlorofluorocarbons, CFCs. So on the left here, these are the primary pollutants and the ones that make up the biggest share. So carbon monoxide is the majority one, and we can see all the others. Now sorry, that's on the left side. And then on the right side, we can see, well, where do they come from? And it's mostly from transportation. And then the other is stationary source fuel combustion. But these are all the pollutants abbreviated, so there's carbon monoxide on the bottom. And look, since the 70s, we've cut them pretty much in half, which is good news. And this is the hole in the ozone layer that's over Antarctica. And basically, I took a screenshot of this. This is a graph since 1979 of the concentration in it. So we've the size of the diameter of the hole, which I believe is what we're looking at. We can see that it is trending downward. So this is just evidence that it's shrinking, which is good news. And then this graph shows measured lead out in the environment. So it's gone down by 99% from 1984 to 2008. And again, like I told you, in the 90s is when it was finally phased out. You can still use leaded gasoline in, I think, boats, but for sure ATVs. Personal aircraft can use leaded gasoline, and I want to say there's one other thing, but cars cannot use it. But so yeah, it's sort of been banned, but we can use it in other things. But cars definitely are the main source of use for gasoline. So there we go. Oh yeah, more scandals. So there's the lead thing, but then Volkswagen last year. Here is what happened to Volkswagen's stock. Just in, what is this, period of like 3 days? Look what happened to their stock. So Volkswagen lied about their emissions thanks to, so if we go back to what this says here, concerted efforts in legislation. The reason this has been able to go down is not because of the free market. The free market is what leads to all of this lead we see in the 70s and 80s. Why did they use lead in gasoline? Because it was really cheap to make gasoline that way. So they're not going to cut. They did everything they could, and they won the battle for almost a half century because they don't want to. They don't want to cut costs no matter what, even if it means dumping lead into our environment. So they resisted it, and eventually we got them when we were able to pass the laws. But so the free market doesn't do these things. Legislation is what does these things. We basically force, it's kind of a mean way to put it, but we basically force these organizations to say, look, you got to get these numbers down. How you figure out how you do that is up to you, but you will be penalized if you don't. Now, what Volkswagen did is they had a computer system built into their cars, which only cleaned up the fuel coming out of them when the cars were being tested. So rather than spending all the money to build the car with the capabilities built in, they built the car to have the capability, but only like for whatever the period of the test was. Meanwhile, so the car on paper says it gets X miles per gallon and it only releases this amount of CO2 and blah, blah, blah. When in reality, the numbers were nothing like that. So it was found out, and Volkswagen got in a huge amount of trouble. They were fined. I don't know how much of this money they have paid out or will pay out, but they were fined $18 billion for this. And look what happened to their stock. It went from $160 a share to, in 3 days, it dropped by something like a third. So, yep, pretty bad when you break the rules. All right, as far as resources from the land go, fossil fuels and minerals are by far the dominant land resource, and we've talked about them enough that we won't say much about them. And we're not concerned with ever running out of these resources, really ever. We're never going to run out of gypsum for making cement, for example. And there's no reason to think we're going to run out of oil or natural gas or coal either. We might graduate and move on and use different things other than them, but we're not going to run out, it doesn't seem like. But we will talk a little bit about environmental hazards. It's unclear exactly how detrimental these are. So I'm not going to sit here and bash the fossil fuel industries, but it is clear that there are some problems that happen. So we're also not going to pretend that problems don't exist. And we're not going to pretend that the problems are a necessary problem. We're not, or at least I'm not going to sit here and say that, yeah, it pollutes a lot, but it's worth it because it creates jobs and things like that. Nope, we can do better than that. We have done better than that, and we're going to continue to do better than that. That's my attitude about it, at least. A big problem with surface mining for coal is it exposes heavy metals that will be in the soil that are normally buried, but because it gets turned up, and then it can rain, and the rain can wash things away. Those are currently allowed to be dumped into rivers. So this was something that the last administration, President Obama, put as a regulation right before, sort of towards the end of his second term, and President Trump has overturned it. So the coal companies are now allowed to dump their mining waste, whatever you want to call it, into rivers because it's a cheap, fast way for them to get rid of their waste. But it seems like it's at the expense of the environment. Now, I don't have any figures that say that the coal companies are poisoning people or anything like that. I'm not going to claim to, but it doesn't exactly sound like the thing to do, that we should be dumping stuff into rivers. If it means that you can't make quite as much money mining coal, then that's just going to have to be too darn bad. We fought this battle with leaded gasoline. Yeah, people need gasoline so they can drive to work and drive to the store and drive to the hospital. But we don't need to have lead in it. If it costs the fuel companies some money, then too bad. It's just going to have to be too bad. And as far as oil goes, oil spills do happen, but they have sharply decreased in occurrence. So this is in West Virginia. This is what's called, oh shoot, no, I can't remember. Hilltop clearing, I think is what it's called. They literally get rid of the top of the mountain. So this is super popular in West Virginia, which we're going to go look at. So we're going to go from Idaho. Oh, geez, I zoomed out way too far. We're going to go from Idaho to West Virginia, which is right here. Get rid of this. And we're going to get rid of the labels too. Okay, so here's West Virginia. West Virginia is the most mountainous state in the country. And you can see it's all green, but you see these little brown patches here and there? That is where they are doing this surface mining for coal. So do you see how it's all forest and rugged hills over here, and then it's like a plateau over here? This is that surface mining, what's going on. Now what happens when they do this, and let's turn on the terrain so you can really get a perspective for what this does. So you can see it's all irregular and jagged. These are the mountains, but then over here all of a sudden it's flat. So I'm not really too concerned with the fact that they're cutting down lots of trees and the mountain is gone, but right below them is the water. So what they do is they take all the stuff that's involved in mining out the coal, and here we can actually see some coal, and they're allowed to just, dump it right into the water here, and then that carries it downstream. And we don't know what happens with it, but we do know that these chemicals are, sometimes it is nasty chemicals that are involved. And apparently stuff like this can happen. So this is a river in Colorado that was stained orange by some chemicals that got leaked into it. So we don't want to see this kind of thing out in nature, I don't think. So we got to just be responsible. But luckily, here's a graph of oil spills since the 70s, and we just know what we're doing a little better. Yeah, the BP oil spill, which you guys were very young when that happened. I can't remember exactly what year that was, but it was like 2007 or 8 or something like that. It was a pretty bad disaster, but those things, they don't happen nearly as often as they used to, luckily. Deforestation, another land resource. So this one is also complicated because in some areas the forests are recovering, while in others it's depleting. Now, tropical forests have suffered the worst by far. Half of all the tropical forests on our planet are gone now. So we've only been going into those places and cutting down trees for 150 years at the most. And we've already cut half of them down. So the rainforest supports a gigantic wealth of biodiversity. There are countless types of medicines and things that we have developed from the rainforest. And we shouldn't see those kinds of places disappear from our planet. It would be altogether unbelievable and tragic if that happened. Now, when we looked at Idaho, we transferred basically desert into green. Now, could somebody make the argument, well, that's not a good thing either. We shouldn't be transforming the land from desert into green. Well, that I'm not really going to follow. But we definitely shouldn't turn our rainforests into, well, nothing, which is kind of what we've been doing. Now, the sort of, it's not exactly a paradox, but the amount of forest cover globally actually increased between 2003 and 2012. Those are the last years we have numbers for it. That was probably the first time in over 200 years that the amount of tree cover on our planet has grown. Now, why has that happened? Well, it's complicated. There are regions in Africa and Australia that got warmer and wetter because of the changing climate, and so trees were able to grow. It's not because we're cutting down less trees, and it's not because we are many people are required to plant trees when you cut them down. That's all well and good, but trees don't grow faster at a rate that matches or exceeds the rate at which we need trees, right? If I need to build a house, I need several trees, dozens of trees perhaps, and it takes those trees maybe 50, 60, or 70 years to grow to the point where I can build a house. So it's not exactly a sustainable process, this deforestation. And I don't know what the future holds for it, but agriculture actually is the dominant reason for forest clearing. It's not the logging industry. It's actually agriculture, because people need to grow food, and so they do slash and burn. They clear the forests out. And then another one is some wide-scale agricultural stuff that we'll take a look at. What we have figured out is that we do this thing called selective cutting, which is where we go out and we cut out small patches of trees from a very large spread out area. And that helps the forest grow back faster than it would if we just cleared a small section of all of its trees. That section may never recover, but these tiny ones can recover. So this isn't exactly a forest. This is a farm. This stuff is called palm oil. And if you look at it carefully, you can notice that the trees are all in perfect rows. Now, palm oil is in just about any kind of like snack junk food that you would buy in a store. It has palm oil in it. And because it's palm trees, they can only grow in tropical places. So we are seeing in like Indonesia and China and India, we're seeing huge, this is another reason why the rainforests are disappearing. They're just getting rid of huge amounts of trees and obviously unbelievable amounts of wildlife. By doing this, they clear it out so that they can grow these things. And it doesn't work for the animals that live there, obviously. So there are several campaigns out there to try to like boycott palm oil. Maybe one day it'll sort of be outright banned. I don't know if that's the right answer or not, because obviously there are people that live in these underdeveloped countries that are able to make a living by working on farms. So a company like Doritos or whatever, they use palm oil, so they have farms like this around the world, and people that live there work there, and they make more money than they could any other way. But is it still the right thing? I don't know. It's tricky. That's up for you to decide. I'm not going to tell you. This is in California. If we look at the top left, you'll notice a checker pattern, and it looks kind of weird. What that is actually those are large squared off areas of the forest where they've cut down pretty much all the trees. So this is what selective cutting looks like. They designate one square to be cut down, and they designate another square to never be cut down. If we look on the right half of the map, we can see that same sort of thing is going on, but they're using much smaller areas, which is probably much better, and they're a little bit more irregular. So this is what selective cutting looks like. And as far as farmland goes, like with agriculture, currently 37.3% of all the land that is on our planet is already farmland. That's probably a much bigger number than you thought it was. But yeah, we're virtually farming on every square inch of land that we can. The only realistic way we could ever increase that is through deforestation. And that is what's happening on our planet. And I just don't think that that's the right thing to do, personally. Another problem with agriculture is that by using groundwater, there are tiny concentrations of salt in that groundwater. Now, what happens is you pump that water onto the topsoil, and the salt stays there. The water evaporates, but the salt cannot. So it's left there, and after 100 years, how much salt has accumulated? Not much. How about after 200 years? Well, a little bit more. After 300 years or something like that, it's hard to say exactly. But at a certain point, there will be so much salt in that topsoil, and it does not take very much salt at all, that it sterilizes the ground for at least hundreds, if not thousands of years. So can you imagine the 2/3 of farmland in the United States, the ground all of a sudden becoming sterile, no crops can grow on it? I mean, what's that going to do to us? It'd be terrible, obviously. So the future might depend on desalinating ocean water and importing it to land. That would probably be the biggest agricultural shift that has happened since we've made chemical fertilizers. It's kind of amazing. There's so much ocean around us, but we don't have a way of taking the salt out of it. You can't use the water unless you get virtually all the salt out of it. But if we did, think about all the water we could pump into places like Idaho or places like California that go through drought. We could transform regions of our country that are pretty much desert into areas that are green. And then perhaps wildlife that's been pushed out of some areas could then immigrate into these new greener areas. We wouldn't necessarily have to turn it into farmland, although we probably would since we're spending money on it. All right, part 2 will be pretty short. It's on conservation. So first we'll define it. It's the careful use of resources. So a big uncomfortable problem with farming is nobody owns the water that's under the ground. And I don't think it would work, and I don't think it would be right for the government to step in and say, okay, we now own the water underground. You can only use it with our permission. But the problem is that a farm, so these groups of farms, they're trying to make money. They have every right to make money. So they're going to pump out all the water they can. And if you're a farmer and you only have one life to live, if you make all the money you can, but you do that by pumping all the water out of the ground, and so do all the farmers around you, and then the next generation of people cannot farm, and therefore we cannot grow any food or anything like that, then we have utterly failed as a population. So these are the kinds of scary questions we have to address. It's not an emergency right now, but it is reality. So I don't know what the correct answer is. So conservation got its great awakening in the Americas in the late 60s. An overall public shift in consciousness was triggered by some man-made disasters, and that led to the creation of the Environmental Protection Agency by a Republican president, Richard Nixon. So they passed the, this is actually wrong, sorry. It's the Clean Air Act of 1970. This is the thing that identified those key pollutants we talked about earlier and forced industries to develop ways to decrease emissions of those. And then the Clean Water Act of 1972, which has been called probably the most influential environmental law in the history of this country. This called for the regulation of pollution and an increase in water treatment plants, as well as maintaining the integrity of wetlands. And wetlands are like the Florida Everglades and things like that. The Clean Water Act does not protect groundwater, but there are other acts that do. So these collectively have resulted in massive benefits for us. Has it meant that the energy companies and things like that are not quite the mega industries that they were back then? Well, yes, I guess technically, but also no, because the idea that energy companies are not wildly successful is just wrong. They are wildly successful. Should they be making twice as much money as they do today at the risk of the environment? I say no. Should they be making 5% more money than they are today at the risk of the environment? I would also say no, perhaps. But we have to decide where the line is. So this was the one that really got it going. That's a river and it's on fire. This happened in Ohio, near Cleveland, I think. And it's called the Cuyahoga River. So factories, Cleveland, and you can see some smokestacks over on the left side. Cleveland is famously, more so in the past, like Pittsburgh, was a major manufacturing place. So it had all kinds of factories. These factories, they dumped their pollution into the rivers and nobody gave a rip that they did it. There was no government agency that came around and tested the water and said, hey, you're violating our standards here. That kind of thing didn't exist. The river was so polluted that I don't know how it caught fire, but when it caught fire, it didn't go out. This river was on fire for like 2 weeks straight. So people finally said, okay, we actually understand now what's happening. We didn't know it was this bad, but it is this bad. And they decided to do something about it. So that legislation was passed. Now, the way these acts work is a target threshold is set. So like emissions must not exceed a certain percentage or a certain mass, like weight of pollutants, for example. And it's up to the industries to figure out how to accomplish those targets. The government agency comes around and tests the water, or they inspect the facilities of the place to make sure that they have working safety equipment and things like that are controlling all of these things. So, that's how it was found out that Volkswagen was cheating. And this is how you can think of it like the food and health inspection that a restaurant gets. They don't tell the restaurant how to keep their restaurant safe and clean and stuff, but they have check marks that they go through when they're there to make sure they have the necessary things in place. And it has been successful. The targeted air pollutions that were focused on decreased by 24%, despite the fact that we increased our consumption by 42%, and our population went up by 39%. All right, we're done.